Hello. We're going to talk a little bit about the three different types of loops and also just review some of the loops PowerPoints. And so if we take a look at our first slide that I want to focus on is just to re-emphasize that every loop has these three parts. They have an initialization, they have a guard, and they have an update. The initialization, the guard, and update all use what's called the loop control variable. And we're going to look at the three different types of loops and how that might look for each one. You guys are getting pretty comfortable with using a while loop. If I start a value in a while loop, I'll just say int x is equal to 1. Then I might say something like while x is less than or equal to 50. I am going to print out the value, and then I need to increment the value. So the three parts of the loop, as we start to see this is the initialization. This is what we call the loop guard, where the question is being asked about whether the loop is being entered. So this is the loop guard. The loop guard, if it comes before the execution of the loop, makes or determines if the loop is a pre-test versus a post-test. This is a pre-test loop with a while loop. And we're just going to print out that value, but then I have to make sure that I update, and I'm going to update by adding 10. You could add other things, but I'm just going to do plus equals 10, which is the same as x is assigned x plus 10. Okay? So this should theoretically just print 1 through 10, and it's going to, well, no, it's going to go from 1 to 50, and it's going to print by tens. And actually, if I wanted to, well, let's see what happens. I'm going to have, I think, a problem because it's going up by tens, but I really wanted it to print like 10, 20, 30, 40, 50, etc. But my problem is where I started it. I started it at 1, and when I add 10 to 1, I get 11, etc. So instead of starting at 1, I'm going to start this at 0, and we're going to recompile and see what happens. Now I get what I intended. Notice that it's going down the screen vertically, and that's because of the print line. In order to print it horizontally and not take up as much screen space, I'm going to go ahead and put in a quote plus quote, so it should print horizontally now. Let's make sure that executes before we go on. So there we go. That's a while loop. A second type of loop that Greenfoot will sometimes have you use, but most of the time they have you working with just the while loop. But a second type of loop is the do while. This loop, again, we have to have the initialization before the loop. So because I already have the x variable declared, I'm just going to restart it at 0, or let me start it at 10. And then I'm going to do the following code. And the do while has the body of the loop inside. It gets executed at least once, and then the while statement is afterwards. And I'm going to say while x is greater than 0, I'm going to print that there's a countdown. System.out.print, and I might say something like countdown, and actually I might print that before the loop, and I'll show you why in just a second. So I have like a title, countdown, and then inside the loop I'm just going to print x, and again add in a space just to have a little bit of space on the screen. And again start to talk about, this is my initialization. My guard is after the loop has executed, so that makes this particular loop a post-test loop. And I'm missing my update. So inside the loop here somewhere I'm going to update, and this time I'm going to go down. I'm going to decrement. So an update can increase or decrement. So we did a decrement versus up here we did an increment. Okay. So if I run or execute this second loop, or both loops, we're going to have the first loop. Oh, I need to get my semicolon here. Execute. I have my first loop, I forgot to hit enter and forgot to comment it out so it wouldn't run. So let me do the following. If I comment out this first loop so that it doesn't execute, and I'm only looking at the second loop, but also to get prepared for down the road, if I wanted to actually put in a space, I could do print line and just with nothing, and that would print a blank space. So I should just get the countdown loop if I could type correctly. And now we will try it. Dang it. What do I got? It doesn't like what? It cannot find the symbol X. That's because I commented out the initialization. So if I put that in right above here, we hopefully will be good to go now. And there's my countdown from 10 all the way down to 1. The third type of loop that we have been introduced to is a for loop. And the for loop has the initialization. So I'm going to declare an integer value. X is going to start at 1. As long as X is less than, I'll say 45. And then I'll say I'm going to count by 5s. X plus equals 5. Now remember, if I want to count by 5s, I actually want to start this at 0. No semicolon in here. But this one line of code here does the init, it does the guard, and it does the update all at once. It does the init first, it tests the guard to see if the loop will execute, so therefore it is a pretest loop. And then it waits until it executes code, and if our code was just to output the value of X, then it waits until it sees that value, and then it goes back and will increment. If I comment out our other two loops, just to see how this one's going to execute, see if we have any typos, any errors, and we do. It says X is already defined, so it's telling me I shouldn't use the same variable name. So if I just make this I for index, if I was using like an array, or just use the value I is often used in a loop as a control variable. When we execute, then we're going to get 0 through 40 counting by 5s. So you have each of the three different types of loops, a while loop, a do while, and a for. The while loop is a pretest, the do while is a post-test, and the for loop is a pretest loop. If we go back and glance at the PowerPoints, you can see where the initialization, the guard, and the update occurred in every one of those loops. The definite loop is going to be the for loop. Okay, that means I can determine how many times it's going to execute before it runs, versus an indefinite, which I don't know exactly how many times it's going to loop. Sometimes I can figure it out, sometimes I don't. This is often when you ask somebody to run a game again, or the user decides how many times to execute the loop, is a indefinite loop. We talked about increment versus decrement. It can go up or down by more than one. Nested loops we did not talk about. This code snippet has a nested loop. In here, if you take a look, we've got a for loop inside of an act. So the act method is a continuous loop, and the for loop is simulating a rabbit growing population. That's a little bit of a stretch. We're using the fact that the act is automatically called every single time. It's not a nested loop that we created. If we go back to JDoodle, in a moment I will show you one on JDoodle. Common loop mistakes. You saw that I had some initialization errors. That often happens frequently, so making sure that I have a variable declared and then it's initialized, and neglecting to alter the loop control variable. If I had an infinite loop running, it would the program would run continuously, and it would pretty soon kind of overflow the memory in the computer and stop running. Making the wrong comparison would be an example of, if in a loop, if instead of using the less than, I used a greater than, and I tried to run this loop, I'm going to save this first, just in case something happens. If I execute that code, it's going to try to run the program. And it says this I is 0 as long as I is greater than 45. Well, what happened on that one is it didn't run it at all, because is 0 ever going to be greater than 45? And the answer is no, so it didn't execute. So this, in this case, it has to be less than 45. Okay? If I created an infinite loop, for example here, as long as I'm increasing, if I did something here, if I wanted to start a value and create or force an infinite loop just to see what would happen, I could actually come over here and I could decrement this value and go minus equals 5 and see what happens on an infinite loop. It's going to try to run the program, and it keeps running it, and I would guess that sometime it would actually end up crashing this screen. Okay, so I'm going to just refresh. It'll reload, and I'll have to reload my program. So I can go to my projects and pull up the loop examples that I was just working on. That gives you an example also how you can do that on JDoodle. As long as you're signed in, you can save your code, etc. All right, to end up the PowerPoints, just to kind of glance through the rest of those PowerPoints, these are items that they're going to talk about. That is, that's an example of the wrong test is made with inside a loop control variable. Using a for loop we just talked about, and the fact that we have pre-test versus post-test. Common loop applications. This is what businesses might use them for. And one common thing that we talk about often is an accumulator versus a counting variable. An accumulator will accumulate increments of different values. So I could go back to the program that had my children's ages in it, and if I accumulated all their ages, I would have some value. But if I counted how many children I have 3 children. So a accumulator will add up or go values up by different amounts, and a counter will always increment by the same amount. Loops are often used to prevent errors in programs. They're used for validating data to make sure a number has been entered correctly. You want to validate data because you want to avoid GIGO or GIGO, which is garbage in, garbage out. Okay? If you don't validate your data, you're going to have some issues. And then there are some common loop applications. We talked a little bit about these already, like reprompting. An example would be if you've forgotten your password and it kicks you out. And then again, validating data types, checking to see if values are numbers, etc. So you can look through the rest of this PowerPoint, and the summary is here at the end